Ever found yourself scratching your head over how to pack your backpack for a hike without exceeding the weight limit? Imagine the predicament. You're surrounded by a plethora of items, each with its own weight and value: a compass, a sleeping bag, a water bottle, a tent, all necessary but all with their own burden. The challenge is to fill your backpack in the most valuable way possible without tipping the scales. And while you may think this is a problem unique to hikers, think again. This conundrum is faced by many in various scenarios. Cryptographers dealing with data, investors balancing risk and return, even astronauts deciding what to take to space, all grapple with a similar dilemma. So, what do you pack? What do you leave behind? How do you maximize value while respecting limits? This seemingly simple backpack problem is actually a famous problem in computer science known as the knapsack problem. So, what exactly is this knapsack problem? Picture yourself as a hiker with a knapsack and a weight limit. You have a variety of items to choose from, each with its own weight and value. The goal? To pack your knapsack with the highest possible value without exceeding the weight limit. In a more mathematical context, among a set of objects with weights and values, you must select which ones to include to maximize the total value without crossing the weight threshold. This conundrum, my dear friends, is known as the knapsack problem. It's classified as NP-complete, a term in computer science indicating that while verifying a solution can be done relatively easily, finding that solution, particularly with a large number of objects, can be quite the challenge. Despite its complexity, this problem finds practical applications in various fields. The knapsack problem isn't just a hiker's dilemma, it has wide-ranging applications. Let's delve into a few, shall we? In the realm of cryptography, the knapsack problem has been leveraged to create encryption systems. Here, the problem becomes a matter of finding the correct combination of numbers that, when added together, equal a specific sum. This principle forms the backbone of several public key cryptosystems, providing a robust layer of security for digital communications. Switching gears, let's take a look at finance. The knapsack problem plays a pivotal role in portfolio optimization. In this context, each investment option is akin to an item with its own weight, risk, and value, return. The goal? To maximize returns while respecting risk limits, or in knapsack terms, not exceeding the weight capacity. So the next time you're packing for a hike, remember, you're tackling a problem that even computers find hard to solve. To sum up, the knapsack problem is a fascinating example of how a simple real-life scenario can translate into a complex mathematical problem. It's a brain teaser that challenges us to optimize our choices within a certain constraint. In this case, the weight limit of a backpack. But it's not just about hiking gear, it's a metaphor for countless real-world dilemmas. The knapsack problem is classified as NP-complete, a term in computer science that signifies problems whose solutions can be verified quickly. But finding those solutions, especially for large data sets, is far from easy. This classification underscores the complexity of the problem and the sophistication required to solve it. Its applications are vast and varied, from cryptography, where it's used to create encryption systems, to finance, where it helps select an investment portfolio that maximizes return while respecting risk limits. So the next time you pack your backpack, remember, you're not just going on a hike, you're solving the knapsack problem.